This is your Siva sir. Today we are going to discuss about motion in a straight line. Motion in a straight line topic. So in the previous class, I find in the previous class I explained about motion in a straight line, distance, displacement, velocity, acceleration. All those points were discussed. So now we are going to discuss few more points. Welcome to the class. So welcome to the class, everyone. So join to the class for. So in this topic, we are going to discuss few more points. Okay, like myopia, 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 myopia. Near distance we can see far distance we can see myopia, 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 myopia. For that correction we are using. Bro, what bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. So now you can see this concave lens. So concave lens shape. So you can. So next one we are going to the next. Hypermetropia, 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 hypermetropia. For a distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. For that correction we are using convex lens, convex lens, convex lens, convex lens. Hypermetropia, hypermetropia. New Cartesian sign convention, new Cartesian sign convention. All distance are measured from the pole. Distance are project to along the distance race. Distance are negative, opposite to instant race. Distance are positive, above the principal axis. Distance are negative, below the principal axis. New Cartesian sign convention. New Cartesian sign convention. New Cartesian sign convention. New Cartesian sign convention. Okay. So everybody, welcome to the class. In the previous class, we discussed about okay. So motion in a straight line. Motion in a straight line. Motion in a straight line. Okay. So motion in a straight line. In that, so in a motion in a straight line, we discussed in the previous class. So that's about distance and displacement, velocity, speed, and acceleration. So now we are going to. So what is sir? I know. Pregnant Justin Raj. Hey, hi, how are you? Welcome to the class. Okay, done. So now we are going to the distance. Distance is nothing but length of the path covered by an object. Length of the path covered by an object is called distance. So displacement, the shortest path from initial point to final point. Today so yesterday in the previous class, exactly at 6 p.m. I took the class. So on motion in a straight line every day for grade 11, 6 o'clock it is fixed. You can join to the class so you can learn the concept. Okay, every day at 6 p.m. Every day at 6 p.m. for grade 11 students. I hope it is very clear to you all. I hope it is very clear to you. Now we are going to discuss about distance. Distance is nothing but the length of the path covered by an object. Displacement is nothing but the shortest path from initial point to final point. The shortest path from initial point to final is called displacement. So here we can see speed. Speed is nothing but distance by time taken. So distance by time taken. Distance traveled by an object per unit time. Song was nice. Oh, thank you so much. Distance. Speed is nothing but distance by time taken. Velocity is nothing but displacement by time taken. Acceleration is nothing but change in velocity by time taken. Change in velocity by time taken. So, sir, you know me. Yes, you joined in few classes. So I remember your name, Pragyan Justin Raj. Yes, of course. Okay, so now motion in a straight line in this class, I am going to discuss about equations of motion. Equations of motion, very, very important. Come on, very, very important topic. Your equations of motion. If the object moves, I will tell one case. I will tell one simple example. If the object is started from point A and reached to point B. So at point A, initial velocity u and reaching to the point B. So in your final velocity is v. So it travels certain distances and within time t. So it is moving with the uniform acceleration. The same scenario, the same case, the same example. How can you draw in the form of graph? Now I will draw. So you can see here. I am taking motion in a straight line. 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 Okay, so motion in a straight line. Motion in a straight line, right? So grade 11 especially, exclusively for grade 11 students. Grade 11 you can join JE students, JE neet, JE neet, and we can go for MSET. Okay, MSET students can join to this class. Now equations of motion we are discussing. Equations of motion. Okay, so if the object is, suppose, equations of motion. So I will tell one example. Case. I'll tell one example. If the object is moving, okay. So I'm taking this object here. So this is the object from there. So this object A. Okay, object A. So the object is at point A. So object is at point A. So initial velocity of the object is u. So after reaching point B, so this is a point B. So final velocity is v. So it is moving with uniform acceleration A. Okay, so uniform. So the equation motion is applicable for uniform motion. So we are taking the uniform motion. So uniform motion. Okay. So uniform motion I am considering. Now, so U and V. So A I am considering now. So it time T. So travel certain distance. It travel certain distance. Okay. The same. Whatever I am explaining this one. So how can I take in the graphical method? How can I take in graphical method? So now I am considering here. So in the format of graph I will draw. Just check it once. So in the format of graph. Okay. So now I am taking here. So with respect to velocity time graph. So velocity on y-axis, time on x-axis. Velocity on y-axis, time on x-axis. So everybody be careful, listen. So very important concept. So I'm considering here. So this is the point A. So I'm taking point A. Okay. So object is started with initial velocity. From your 0, this origin. So from 0 to A is initial velocity u. Okay, so it reached to certain position, so that is point B. Okay, so from here, so I'm taking like this, and here I'm drawing. Okay, and here also I'm drawing like this. So this the final velocity. It reaching to the final velocity from 0 only anyway. It's so final velocity will be taken from here to here, and initial velocity will be taken from here to here. Okay, so started with some initial velocity and reaching to the final velocity V. So at V, so final velocity is V. At U, set A, initial velocity is U. Initial velocity is U. Okay, initial velocity and final velocity. So we can take this one. So now C, D and E. So these are the points. These are the points. Once again, so what are the points I'm considering? You can observe here. What are the points I'm considering? You can observe here. Okay, so this is the point C and point D and point B and point A is here and here, so E. Okay, so these are the points. Now you can observe. Anyway, this also time T only. This portion until this one. If you are taking the magnet, this one also we are taking T. So this also until this one. This component will be taken as T. Okay, so time we are considering. Now velocity time graph. If you take velocity time graph. So I'm considering the velocity time graph. Now observe, very important. So very important concept I'm explaining. Okay, anyway this scenario is over, right? So I'm removing this one. So you can take the same case. Okay, so once again I will draw. So here I'll draw here. If you want, I will draw. So I'm taking on object here. Object is at A. So object is at point A. So point A and object reached to point B. So initial velocity is U. Okay, I'm considering initial velocity U. Final velocity is, so time T and distance A, acceleration A. Okay, so now you are considering same case, same scenario. I'm taking in the form of graph. In the form of graph, how I have to represent. Now we will see. Okay, so now I'm considering here. Check once. Okay, so fine. So now you can see. So anyway, this is a graph. Now I am considering from velocity time graph. If you are taking velocity time graph. Okay, so BC equal to BD plus CD. Okay, so BC equal to BD plus CD. Okay, so BC we know from here to here, we know velocity. What is that? Final velocity. So final velocity. So BD we don't know, so leave it about it. BD we don't know, so leave it about it. CD is nothing but initial velocity. So OU, that is nothing but if you are taking, so in this case either CD or OA equal to U, initial velocity. So I'm taking initial velocity. So BD equal to initial velocity V minus U. So V minus U. So from the velocity time graph, from velocity time graph, okay, from this graph, from the graph, so we can take acceleration equal to acceleration, slope of AB, is nothing but acceleration, that is nothing but BD by AD. So BD by AD. So AD is nothing but here. So what is AD? AD is nothing but OC. 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 That is nothing but T. That is nothing but T. So you can substitute here. So A equal to BD by AD is nothing but T. From this, so BD equal to A into T. So very, very important, A into T. Now, so keep in bracket this one. Keep in bracket now. So BD equal to what? AD. So A into T. So V minus U equal to A into T. From this, V equal to U plus AT. So V equal to U plus AT. So this is equation 1. Very, very important. Yes, ma. So yes, it is there in 9th grade also. Even in plus 1 also it is there. Okay, equation of motion. So very, very important. Once check it. So check once. So again, I am taking the same scenario. Object is at point A. So initial velocity U. After certain time, it travels certain distance with uniform acceleration. So that is point B reached to point B. That is final velocity is V. So this same scenario. So the same case we are drawing in the format of graph. So we are taking y-axis, T on x-axis. So I'm considering point A is initial velocity, reached to point B final velocity. So we are drawing this one CD. Okay, so this distance, we don't know this distance, but we know final velocity, we know initial velocity. Anyway, by applying this one, we can get to know V minus U. But from graphical method, we have to find out. So BC equal to, so you can observe here, BC equal to, okay, so BC equal to BD plus CD. BC equal to BD plus CD. So yeah, CD nothing but OA. So here we can take these terms I am writing. What are the terms? AD equal to OC. That is nothing but T. And CD equal to CDR equal to OA. That is equal to initial velocity. So these terms are very, very important. So every day will apply these terms. So keep in mind this one. Okay. So now we are considering. So BC equal to BD plus CD, and BC is the final velocity and CD is the initial velocity. So we are considering from here. Then BD equal to V minus U. From the graph, so slope of AB. So general directly we can write slope of AB, that is nothing but BD by AD. BD by AD. Because we are taking this one. This is the slope. This one we are taking the slope. Slope you are considering. So BD by AD. That is nothing but acceleration. So AD is nothing but T. So A equal to BD by T. So BD equal to AT. If you substitute V minus U equal to A into T, V equal to U plus AT. So that is equation number 1. So equation number 1. I hope it is very clear to you all. Yes or no? So next one we are going to the one more condition. So position and time graph. Very, very important. So very neatly I am writing. So make sure that you are following this one. Okay, very, very important. So next one, position and time. So coming to the position and time. So like but S and displacement, that is the position we are taking. So S and ST graph if you take. So position and time graph if you are considering. So the distance traveled by an object is under the area of this graph. I am taking this entire portion is trapezium. So S equal to, so this is a rectangle format. So OA into AD plus, so this portion also there, right? This is in the form of triangle. If you are taking half into base into height. Base is nothing but AD and so height is nothing but BD. Now, so S equal to OA is how much? Initial velocity into, so we are multiplying. So that is nothing but into AD is what? AD AD is equal to T. AD equal to T. AD equal to T. So now plus half into AD is how much? AD is T. AD is T. So into BD already we found, right? That is AD. So BD also you have to write. So BD also we have to write. That is nothing but A into T. So this is also very important. So make sure that A into T. A into T. So S equal to UT plus half AT square. 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 Okay. So next one, position and time, position and velocity graph. Position and velocity graph. From that graph, so the area under this one is trapezium. So trapezium, if you are taking, so two parallel sides we have to add OA plus BC, OA plus BC, OA plus BC into base. So that is nothing but OC by 2. So now we are considering S equal to OA is how much? Initial velocity plus BC is how much? B is the final velocity. Final velocity V into, so base how much? OC equal to T. OC equal to T by 2. So from here, so already we know the equation. First equation is V equal to U plus AT. V equal to U plus AT. From this equation, V minus U equal to A into T. From this T equal to V minus U by A. So T equal to V minus U by A. So write down this one. So substitute in this case. So in the case S equal to U plus V into, so V minus U by A into 2. So then if you do it, how much you will get? S equal to, so this is in the form of A plus B into A minus B. So we know the A plus B into A minus B, A plus B into A minus B. So A minus B, that is A square minus B square. Is A square minus B square. A square minus B square. I hope it is very clear. So A plus B into A minus B, A plus B into A minus B, A plus B into A minus B, A square minus B square. So now you are taking here V square minus U square by 2A. So V square minus U square equal to 2A. Yes. V square minus U square equal to 2A. So this three equations. So once again you can observe. Very very important equation. Till now I explain. You can observe here. So equation of motion from graphical method. Because I can't so place all the equations in one board. So you can see from here. So I wrote here one first equation. Now you can see. So the object is there. Object is at initial position A. So it reached to final position B. So initial velocity at the time t equal to 0. Initial velocity I am taking. Initial velocity is U. And reaching to the final position. So final velocity is V. Okay. So time and with respect to distance also it is moving with uniform acceleration. The same scenario we are drawing in the format of graphical method. Same scenario, same case. We are drawing in the format of graphical method. So velocity on y-axis, time on x-axis. Velocity on y-axis, time on x-axis. So at point A, initial velocity, at point B, final velocity. So base we are taking this component, that is until this component, that is magnitude, we are taking time. Okay. So here we are taking the BC and BD. So now, so from velocity time graph, first equation is from velocity time graph. From velocity time graph, you will get V equal to U plus AT. From so position and time graph, you will get S equal to UT plus half AT square. From position and velocity graph, you will get V square minus U square equal to 2AS. Sir. So we know this one. So we can do it. So but the same equations I will explain in the format of integration. Okay. So the same equations I'll explain to you in the form of, okay. So with integration method I will explain. So with integration method I will explain these three equations. What are those? So v equal to u plus at, s equal to ut plus half at square, v square minus c square equal to 2s. So these three equations. So with integration, I will explain. Just carefully observe. Okay. So now I am explaining. So be ready for the explanation. Now I am considering. Okay, same case. Object is at rest. Object is at rest. I'm taking here. So initially object is moving with uniform acceleration or with a constant acceleration. So time t equal to 0 and at certain time t. So initial velocity is u, final velocity is v. Initial velocity u, final velocity is v. So now we are taking the velocity if you are taking. So derivative of d by dt if you are taking acceleration. So dy by dt equal to acceleration. So very important. Now you can observe. So dv by dt equal to, so dv by dt equal to, okay, so acceleration. So dv equal to a into dt. So with the help of derivatives, and integration. So if you are taking integral time, so velocity rise, initial velocity u, final velocity v. So dv if you are taking, okay, so under time 0 to t. So v equal to a into integral, so time t equal to 0 to t. So time into integral. So interval we are considering limits. So until what limit? 0 to t. That is tt. So now you are considering v into limit. So u v, and so here I am considering a into, so t, so limit 0 to t. So now you substitute v minus u equal to, so anyway a into t minus 0, then we will get v minus u equal to at. So then nothing but v equal to u plus at. So this is the first equation. Okay, equation number 1. So coming to the equation number 2. So equation number 2. So same we are taking v equal to u plus at. So how velocity will come with respect to displacement? So displacement, if you are considering ds by dt, we can x also we can take. Distance only, right? Distance we can take x also. You can consider ds by dt equal to, so u plus a into t. So take integration. So ds equal to u plus a t into dt I am considering. Now integral what you are taking? 0 to s. Displacement starting and certain distance only, right? Starting is 0 only, right? So here and reach it to certain distance. So certain distance 0 to s limits, and u integral, so t equal to, so 0 to t. So time 0 to t only, right? So 0 to t limits I am taking, that is dt plus a into, so here t is there. So integral x dx equal to x power n plus 1 by n plus 1 you are taking. So integral t equal to, anyway 0 to t you substitute, 0 to t I am considering. So t dt, then if you are taking here, so yes you will get s minus 0. So anyway limits we are taking like this, and u t minus 0, and here plus a into t square by 2, that is nothing but 0 to t. So now if you do it, s equal to ut plus, so here we will get at square by 2. So that is nothing but s equal to ut plus half at square. This is the equation number 2. S equal to ut plus half at square. S equal to ut plus half at square. S equal to ut plus half at square. B equal to u plus at. S equal to ut plus half at square. So next one, third equation. So I'll explain third equation. You can check it. So equation of motion, third equation I am explaining now. Okay. So here we are taking v equal to u plus at. So v equal to u plus at. So square on both sides. So v square equal to u plus at whole square. Then v square equal to u square plus 2at u into at square. So here I am considering v square equal to u square Plus I am taking 2a common. Here 2 is not there. So ut plus of at square. So here 2 is not there. Oh, here both it is there, right? Square we have to take both sides. A plus b whole square formula here. A plus b whole square formula. A square plus b square plus 2. So according to that formula, here u square plus 2at, so 2ab and b square is nothing but so whole square. From that, if you are taking 2a common, from that you can take 2a common, you will get 1 by 8 square. Now, so v square equal to u square plus 2a into, so what is ut plus half 8 square? Ut plus half 8 square is yes. Ut plus half 8 square is yes. So you can take here. Ut plus half 8 square is yes. Now the final formula is v square equal to u square plus 2as. So v square minus u square equal to 2as. So these are the three equations. These are the three equations. I hope it is clear to you. Any doubts? Okay. So until here, so equation of motions. So today we discussed three equation of motions. So that's enough. So we'll discuss remaining points. Remaining points we'll discuss, and those related to these equations we'll do problems also. Related to this we have to do problems. We have to do problems. Those I will explain in the next class. Problems we'll discuss in the next class. Be ready for it. So problems which will take time. So that's why we are I'm taking next class. So problems. So if you like this video, please do like, share and subscribe to Student the Brand. So this is your Siva sir. So thank you so much for joining. And Ram Lakshmi, hi again. End of the class you are joining. So everyone, so thank you so much. If you like this video, do like, share and subscribe to Student the Brand. Until that one, we'll do problems tomorrow class. Thank you.